Yeah, we started recording. So, good day, everyone. Welcome to week 6. Can you see my screen? I need to be sure you can see my screen. Okay. Welcome to week 6 of the GIDA um, Skill Up Summer Bootcamp, right? And in this week, we'll be talking about testing in Starknet. And I'll be taking this class. And my name is Weval. So, let's jump right into it. But first of all, before we go into it, I want to hear a little bit of what you learned in the past week, or what you learned in the past few weeks of learning Cairo. If there's any question or something, I just want to hear your opinion on what you learned previously in the previous week. Anybody wants to comment on that before we move on into today's class?
Okay. GM guys.
Um,
Last week I was able to learn components and how components are dependent on the smart contract itself. Now they can be deployed independently, but they have to be embedded into the smart contract. Also learn the dispatcher and some other thing, but mostly I learned about components last week.
that was nice. Yeah, it's good that we have the experience of component of working with component, and we're going to be using a little bit of that in today's class, hopefully. So yeah, we read from you, and I think we'll just go right into the class since nobody else wants to speak. So we'll be having 3 sessions, which is introduction to testing in Starknet, which is what we're going to do today. Then advanced testing techniques, we'll cover that tomorrow, and practice and assignments, we'll do that on Friday. So for session 1, we have a few topics that will help us to outline what we're going to do today. And the first thing is introduction to testing in general. Then why do we test? Then basic unit tests, writing the counter contract and testing the counter contract. So if at any point you have any question, please make sure to ask or raise your hand in the chat and ask your question. So first of all, I'm going to be going through a little bit of introduction to testing, and I will just explain. I'll just explain what testing in general. So testing is an important part, all right. Not just like, let's go away from smart contracts a little bit, right? And let's talk about real life. So, for example, you're trying to make food, right? And you are adding a little bit of salt in the food. I know this is all the edge, but then most times, what we do when we add a little bit of salt, we usually taste it, right? So, but I'm already drifting. But then that's basically what testing is, to check that what we expect or an expected outcome or how we want things to go, like it goes that way. All right. So testing is essential in developing any software, be it smart contract, be it front end, be it website. Testing is important in developing any piece of software, especially in smart contracts, where correctness of the contract is very paramount and crucial. All right. In the context of Cairo, writing code that is secure is very, very important. Why? Because there are a lot of cases where we hear about this very often, especially Web3 and blockchain, where because of a little bug or because of a little error in the code, or some edge cases that were not handled properly, because of those little things, a lot of money is lost, yeah, of protocol hacks and all those. So that's why testing is very important to ensure that only authorized users, right, have access to the contract or to the assets in the contract. All right. Also to ensure that the logic of the contract is valid and is sound. Right. Those are why we test. So let's just go to why do we test. First reason why we test our contract or our code is to verify that this contract behaves as expected, which I've mentioned earlier. Also to identify and resolve vulnerabilities. So when you're writing the code, you don't want to have to deploy before you can identify vulnerabilities and solve them. So you do that during testing. And another reason is to simulate real world use cases, and most importantly, to prevent financial losses, which we've talked about. All right, so that's basically why we test. There are so many other reasons, but these are the ones I listed here. Then we're going to talk a little bit about types of tests. Right, if you've been in software a little bit, you should have heard these types of tests. There is the unit test, there is integration test, and there's end-to-end tests. I didn't write that here in particular because Cairo basically mostly provides provides support for writing unit tests and integration tests. All right. So what is a unit test? A unit test is basically a test that you perform on an isolated function. All right. It's isolated testing of individual function or contract component. I'm speaking a lot of grammar. When we write the code, you're going to understand more of what a unit test is. So a unit test is usually involves testing a single function, all right? Usually involves testing a single function or a single part of the code. Then integration tests how the contract interacts with other contracts, right? So integration test is a little bit more complicated than writing unit tests because it involves you testing how the contract works and handle different scenarios with other contracts. So next, okay, the anatomy of a test function. So as I said earlier, a Cairo test is basically a function. Is there anybody there? Give a reaction in the chat if you're following. That's good. So a Cairo test is basically a function, right? It's simply a function that tests that or that runs to confirm or to verify that the code performs as expected. Right. So the anatomy of a test function. This is typically for an integration test most cases. A typical test function follows three steps. All right. It has the setup where you initialize necessary data or states. All right. For example, if you want to test the contract, all right, and we are testing it in our test environment, not on the deployed blockchain. But to be able to test the functions exposed by those contracts, we have to set it up by, for example, passing the constructor data. I believe you know all this concept I'm talking about. If at any point there's any concept or anything I'm mentioning that you're not familiar with, you can ask. So the setup usually involves passing the constructor data, declaring the contract, deploying the contract. That's usually the setup part of our test functions, and then run, which is executing the code being tested. And then there's always an assertion, which verifies that the results, which verify the results against expected outcome using assertion macros. Cairo provides several assertion macros, including assert, assert EQ, assert any, and so on. Right. So that's about the anatomy of a test function. And we're going to be seeing them when we start writing code. Does anybody have any questions so far? Or we can move on. No question. Okay, so yeah, let's dive into the code. So I believe you have worked with um Scab. If you have Scab installed, please um if you have Scab installed, please leave a reaction in the chat. I don't know if you can see my terminal. Is my screen big enough or is it too tiny? Can you see my terminal? I'm not getting any response. Okay. So if you can,
Sorry, please.
yes, I didn't get you. I didn't get your question.
Okay, I said, like, can you explain the meaning of the assertion macros, like the function, if possible? Can also give
Okay, we're going
examples.
to we're going to see them when we write the code. But basically, what an assertion does is just a way of verifying that this will equals to this, or this is this, or I don't know if trying to explain it with words, this might not make sense. So we'll try to explain it when you're seeing the code, right? But just know that assertions are used to verify or to assert that a value is a particular result, right? But we'll see more of that when we start writing code. So I think I've created a folder here for that. So you can basically do scarb new to create a new package, and I can name it um I don't know what to name it. Basic test. I don't want us to use Starknet Foundry for now. So I can open up folder. None of that should be strange to you by now. And I have my VS Code open. So yeah, we're good to go. Sorry. So can you see my screen? I want to be sure that you can see my VS Code right now. I think because of the way I'm opening this, I can't really see the reaction in chat. So I think I'll leave it like this. So if you can see my VS Code right here, you can see this is the boiler or the template code that Scarp generates for us. And we can get rid of this. So we just get rid of this. Okay, our Scarp.tom is okay, we can keep it at that. So basically what we're going to starting with, we're going to be starting with a little bit of unit tests, right? And as I said earlier, unit tests are tests that you write for particular functions, right? Or individual components or functions in your contract, right? But for now, we're going to be writing a simple Cairo program, and then we're going to be testing it. So I think we should work on a calculator, right, which will have functions like adding, addition, subtraction, and so on. Right. So right here in our lib.cairo, we can start writing. But if you remember, your main function is the entry point to your Cairo program, right? So you have to define our main function first. And then we can go ahead to start writing the different functions for a calculator like program. So I want to be sure that this code is not strange to you guys. And what I'm writing here is not strange. So basically, for an addition function, we just want to have two parameters. Let's say x, y, and as a return value of u64, then we can return simply the addition of both, return x plus y. Then let's write a subtraction function that takes two values also, u64, u64, returns the u64. Now we can say x minus y like this without putting a semicolon and the return keyword. This would automatically just return the result of this subtraction here. So now basically what we have here is our um our simple addition and subtraction function. I hope I'm still audible. And we have our main function. We can just say, let's say, add 4 and 3. And that's supposed to give us 7. If I'm not wrong, I can open up my terminal. You can open your terminal using control or control backtick. And I can see, let me try building the program. Yeah, and it works. So basically, if you have been introduced to Scab, you know Scab is like the npm for Cairo. If you know Node package manager, this is like the package manager for Cairo. So Scab has the command, which is the test command, which we can use to perform testing operations in our VS code. Yes, I have to put this to the side. So you can see I just ran scab test, and one the saying scab Cairo test is duplicated. I will remove the future versions. But then we can use scab Cairo test. But what we like to do, we like to add this into our dev dependencies in our scab.tom. So you can just do this inside your scab.tom, add the Cairo test. Even though it's going to be duplicated later, we can use it for now. But in most cases, you are going to be using the Starknet Foundry SN Forge for testing. But since we are just writing a simple Cairo program, we can do this. Right, and you can see, if you can read the results here, you can see compiling tests, basic tests, which is the name of our package, right? And unit test. right? You can see, and it says finish testing basic test, running zero test. Test result, okay, zero pass, zero field, zero ignored. And why is that? It's because right now we have no tests in our package. There is no test written anywhere, but we will get right into writing tests. All right, so to write tests, unit tests in Cairo, right? The convention for writing unit tests in Cairo is writing it directly in the same file or in the same module as the function or as the individual function you're trying to test, right? Which we have right here. The functions we're going to be testing for now are this add function and subtract function. So writing our unit test, we can keep our unit test right inside the same file, right? But in if we're writing integration tests, we'll most likely create a separate folder and keep our integration test there. But for the unit test, we can keep it right here. And how we do that, we use the CFG attribute. Right? This is the syntax. And inside parentheses, you write test. That's the CFG attribute. Are we following? I'm trying to take things as slow as possible. Then you write your unit test inside a module. Right? You can give the module whatever name you choose. But I'll name mine test. Right. So with this module, inside this module, then we can write test functions that we'll use to test this right here. All right. Are we following? I'll see reactions. Anybody was anybody able to get write their addition and subtraction functions? Are there people on this call? Was anybody able to write the addition and subtraction function? Because now we're going into testing. We've written a little bit of code and we're going to be testing that code. So now this is basically what you need to start writing unit tests. Once you have this configuration attribute here, then you just create a module under it, and then you can start writing your test functions right there. So now inside your module, you have to add the test attribute on the test functions, right? The functions that are going to be test, these are basically just normal functions. So functions that are test functions need to have this test attribute right above it, and then you start writing your functions. So you can say test, this is the name that I want to give this function, test add or test addition. Then this is now where we use the assert macros, right? So now basically they are assert macros are basically just functions, right, that Cairo provides us with that we can use to make different assertions in our code. We have the assert, we have the assert EQ, which is used to assert that two values are equal to each other. We have the assert ALT, which is used to assert that one value is less than the other, assert GT, and others. So I think we'll use this, but for now we can comment this out. Will not be, I can even get rid of it. So for our basic tests, all right, I'm going to be doing a simple assertion. This is the first test we're going to be writing in this. But before we do that, we have to um import these functions, right? Now these functions are in the parent module. We have to import them into this test module, right? And we do that using the use keyword. Use, and we can use the super keyword, which exposes the functions in the parent module. Are we following? I need reactions. I need you to be proactive. So yeah, I believe you have been taught about super use modules. So that's why I'm using those terms here. So you can just say super, and we can import more than one function at a time. Add div. Now because these functions are made public, we can import them right into this module here and start using them immediately. So inside this our assert function now, basically how this assert works, right? It takes two it takes two parameters. So let me just write the parameters here. It takes a boolean comparison, and it takes a boolean which you can get by doing a simple comparison, and an error, right? So it takes two values, right? A boolean value and an error. A boolean value, I'm simply talking about true or false. So it's going to assert that something is true, or it's going to return the error you define. So basically, I'm going to start writing the assert function. I've been talking too much. So let's say assert that. Let's say assert true. No, let me use the add function. Add 2, comma 5, because that's syntax, right? It's expecting two arguments, x, y. So we can just pass 2 and 5 into the assert. Right. Now, what this does, right? This add 5 is going to return what? It's going to return a value, which is a U64 value, which is going to be 7. So now what we want is to make is to have a comparison. Now, if we do this, assert 2 comma 5 equals to 7. Now we have a comparison, right? Now this comparison, when we run this code, is going to compare that the result of add 2 comma 5 equals to 7. If that is if add 2 comma 5 equals to 7, what are we going to get? We're going to get true, right? Which is a boolean. But if not, we're going to get false. So we're simply just passing a comparison, right? For this assert macro, basically takes a comparison and checks that that is true, else it throws an error. So let me just try to run this. Let's see what we get. So now we have our first test set up. So when we run tests, cap tests, we should be seeing, okay, now I'm saying, oh, I imported a function that we don't have, and nobody could tell me. So the functions we actually have is addition and subtraction, right? I thought we already had division. So that's the error it was trained here. Did not compile. Yeah, I missed the semicolon. So the semicolon is very important. I'll clear the terminal to make it. So now you can see we have been able to run our first test. I believe we're following along and running our test also. So with the first test, it says running one test, basic test, and the name of the test module is test, and the name of the particular test is test addition, and it says okay, the gas used 301 passed. So now why the test is passed is because this comparison goes through. If I should change this value from add 25 to add 2 comma 5, which is going to give us 7 equals to 8, we expect this test to fail, right? Because now this is the assertion that you were asking about. So this test is going to fail. Why? Because the assertion is going to be wrong. So you can see it says test result failed. You can see it says test addition and failed. Panicked with assertion failed. add 2, 5, it equals to it. So it just basically returned the function that the assertion failed from. So basically, when I was giving you this, I said the assert function takes a boolean which we get from this comparison and an error. So now we can now pass in what the error we want it to return if this assertion fails. All right. So in now if you look at this, it just said it's panicked with this. So this is the default assertion error that it will give us. But if we want to say, let's say add 2 comma 5, which is 7, because it want to say something like 2 plus 5, or addition not equal to 7. That's so if this assertion fails, we want to return this error. Addition not equal to 7. Now, because we have 7 equals to 8, which is 2 plus 5, we're comparing it with 8. That's why we have this double equal to sign here. We are expecting to see this assertion error. Right, so if I run my scarp test again, now you can see saying panicked with addition not equal to 7. So it's no longer panicking with their default um, error. Now it's panicking with addition not equal to 7. Do we get that? Because basically this is the same way most of these assertions are going to work, right? Just that they might require different parameters or arguments, but basically this is how the assertion is going to work. So now we have written our first test, but now this for this test to pass, this has to be equal to 7, right? So assert that this equals 7, else we throw this error. Now if we run this test again, it's going to pass and it's not going to throw any error. So you can see one passed and there's no error. So we can go ahead to test our subtraction function, and basically we just write another Cairo function but with the test attribute inside our test module. And all these tests we are writing now, if you can see, they are all unit tests. Now we can go ahead to use another assert macro, right? I was listing some assert macro to you. So we can use the assert EQ. So for the assert macro, right, it expects a boolean and error. These are the arguments you expect. While for the assert EQ, which is basically assert equals to, right, it expects three three parameters, right? Let me just write it here. Expect 3 parameters, which is the first value, the second value, if you don't, if at any point you don't understand, and then the error. Now, basically, these two functions will do the same thing. Just that here now we are asserting that this is just expecting any boolean. Any boolean scenario is going to throw the error. Whenever it's false, it's throwing the error. Whenever it's true, it's passing the test. But for assert equals to, right, it takes two values. Let's pass the first value, and then the second value, let's say 9. Right? And if these two values are not equal to, then it will throw this our error, whatever error we pass here. Right? So that's basically how this assert works. Are we following? Do we get that? So if I run this test, I expect it to fail. Why? Because 4, which is the first value, is not equals to 9, which is the second value. And when this fails, it's going to throw this error, right? 4 not equals to 4 not equals 9. Let's just try this. And we can see the first test pass. Now it's running the two tests. First test pass, test addition, okay. But test subtraction is failing. It's failing with what? Panicked with assertion 4 9 failed. And it's saying 4 not equals 9. So that's basically how the assert equals to work. But now in our case, we want to use this assertion to test the subtraction function, right? And what the subtraction function expects, it expects two arguments. So let's say subtract 10 comma 5, and we expect 10 comma 5 to give us what? 5, right? Which is 10 minus 5. 10 minus 5 will give us 5, and we want to assert that this 5 which will be returned here is equal to 5. So we want to ask, I don't know if you are following and if you understand. Does anybody not understand up to this point? I feel like I'm explaining to myself. Okay, we understand what's going on here. So, so basically, the value that's going to be returned from subtracting 10 minus 5 is 5. So we want to assert that this first value is equal to the second value. Else, we'll throw this error. So now we can see assert that subtracting 10 minus 5 is the same thing as adding 2 comma 3. Why? Because subtracting 10 minus 5 is supposed to give us 5, and adding 2 comma 3 is supposed to give us 5. So you can say if not, say result not equals 5. This is basically how even your complex test is going to be like. It's going to end up being just assertions. That's why when we're talking about the anatomy of a test, we talked about the setting up the initial data, and that's most times this setting up involves a contract. In this case, we're just running a simple set of functions in a unit test, and then the assert is just to verify expected outcomes. So in this case, we are verifying that subtraction returns the correct value and addition returns the correct value. So if we run this test, we expect the two tests to pass, and yes, test subtraction is passing, test addition is passing. Why? Because the result here is going to give us 5, and this result here is going to give us 5. Else, if we change anything here, or if we change anything in our code, right? Let's say we do this x plus y plus 1. This test which we have here will automatically start failing. Right? That's the importance of testing, to ensure that our code is not broken at any point, that there's no mistake. You can always run the test. Now, just that simple change I made, you can see our tests are failing for the both scenarios. You can see results not equals 5, addition not equals 7, right? So basically, let's just fix this. And basically, that's the first two assert macros that we're talking about. The others, let's also use assert not equals to and assert less than. But before we do that, we can just add other functions. That's we'll need in a calculator, let's say assert, multiply. We'll be using it to assert that multiplication works. This is for use is for um basically just a simple multiplication function, nothing too complex. This is for 64. So yeah, we have to pass the return value, return type, and just use cab format. Then remember when last I did that. So basically that just formats your code. I don't know if you even saw that. I was too fast. So if you run scab fmt, is a function provided by scab to just to just format your code properly to maintain the normal spacing and all the stuff. So now we have more functions that we can test. So we'll be using our other assert macros to test these functions. So let's say we have to, first step is to write what the test attributes above the test function. Then we want to test multiplication. And now we're going to be using the assert LT. Now the assert LT macro is basically for asserting that a value is less than, right? But now what it expects, similarly to assert EQ, sorry, it expects the first value, second value, and the error, right? So basically, it's asserting that the first value is less than the second value. So that's how this assert LT macro works. Assert that the first value is less than the second value. Let's say 4 is less than 6. Else, throw this error, else not less than 6. Right? So now we can test the multiplication function just right here. Basically, we're just testing random things, but in a real world application is when we're going to be using this to test edge cases in our smart contract. So basically, I'm just teaching how to write unit tests. That's what we're doing today. How to write unit tests and how to use the test attributes and other attributes and assert functions. That's what we're learning today. And then so basically it takes two parameters, right? Let's say 3 and 2. So if who can tell me what would be the outcome of running this assertion? Yeah, you can just turn on your mic and speak. If you know what the result of this assertion is going to be, is it going to pass or is it going to fail?
It's going to return not less than. It's going to fail.
Yeah, it's going to fail. And why is that? Is because 6 is not less than 6. They are equal to each other. So we want the first value to be less than the second value. So for that, we need to change this if we want the test to pass to a value that is greater than, and then we can run the test again. saying, okay, now the reason why saying function was found, if you remember when we were dealing with the other functions, we had to import them, right? But we failed to import the multiplication function. That's why in Cairo, we have to use the use keyword to expose functions, right, for the compiler into different modules, because by default, all these all these are separate modules, right? Even though they are in the same file. To do multiplication and division functions. Now we have them here. Let's try let's try it again. Now you can see it has completed the three tests, test multiplication, and each of the tests is three passed, zero failed. None of them failed, right? Because the assertion was what? Correct. But had it been we had left this at 6, the assertion will fail. So basically, you can test different scenarios using just this simple assert. Let's add another assertion to this. Assert GT, right? Now let's see, multiplying. Let's assert that the first value, now the same thing, the same way it works for um, assert GT. So what it expects also is basically first value, second, and then the error. Right, but in this case, we're going to assert that the first value is greater than the what? Second value. That's what it's going to be asserting. It's going to be asserting that the first value is greater than the second value. And so what we can simply do, a simple assertion that we can do here, we can assert that multiplication is greater than addition. All right. So let's see, assert that 3, 3. Then we add the comma outside and say so it's greater than adding 3, 3. So multiplying 3, 3 is going to give us 9, and adding 3, 3 is going to give us 6. So this should check out. Else addition is less than, or is, sorry, or I don't even know what to name this. Multiplication is less than the addition. I'm just giving random stuff, so don't blame me. Like, so how many tests are running now? We have 3 tests still. Why? Because these two assertions are in the same test, so we can write multiple assertions in a single test to assert for different things. And if a single assertion to fail, right? If a single assertion will fail in the test, the test will fail. To confirm that, let's
So
change this back to
just
6.
to get
Yes,
to just to get to
I
that, if one, let's say you wrote 10 assertions in one single
yes,
test. So if
yes,
one have a little fail, one fail to affect all of them.
yes, the test will fail. That's what we want to do now. So that's why I'm returning this to 6. And if this is 6, it's no longer less than, right? So now we expect test multiplication to fail because of that assertion that is wrong. So now when I run this test, you can see the other two tests are passing, right? But this test multiplication is failing. Why? Because of what? Not is not less than 6, right? where is it here? Yes, you can see it here. So this test is failing. Test multiplication is failing because of that single assertion that was wrong. All right. So even if you have multiple assertion, once one assertion breaks, it ends the test. It fails the test automatically. So that's it about using assertions in your test. Right. In most cases, you will be using assertions to assert, for example, to assert that a token has been transferred, or to assert that there is enough allowance to transfer a token, or to assert that the caller is the owner. But in most cases, you'll be using assert a lot for testing. Right. That's why we are going through each assert macro that we have in Cairo. So we've done the assert, we've done assert equals to,
So,
yes.
so that your code. Can you go back to your code? I saw some. Okay. Can you explain this assertion assert greater than? Because he used in terminology in that assert less than, he used not less than 6 in the double quotes. So in this second one, should we not use greater than instead of multiplication is not less than add? Can we
You
just
can
use
use
greater?
anything. You can use anything in your, anything that will to be able, that you'll be able to understand what went wrong in your code, right? It's basically for you to be able to understand what went wrong. All right. So whatever I'm writing here, I'm just, that's why I was just writing random stuff. Right. But in a real scenario, you want to write a proper error message. Right. For example, if you have a kind of like a function, right, that allows a user to vote in your smart contract, right? And in your test, you are testing whether the vote is counting, right? For your error scenario now, you can write something like voting field, or something more related to your um use case, right? Do you understand what I'm trying to say? So that when you see that error, you'll be able to identify that, okay, is this particular assertion that failed. Do you understand? It's just a way to get a descriptive message about what went wrong in your code. So it could be anything. There's no, it doesn't matter what I write here. So now, even further, we can write custom error messages, right? Can write custom error message in our code instead of just having this. Let's see, we can now say assert. This will still fail, so let me just fix it. Or instead, let me test another function. So the first step is to add the test attribute to the function and then define the function. So I want to assert that dividing 20 by 2 is going to give us 10. So basically, as I was explaining earlier, this assert macro, right, without any asserts, whatever, this is simply an assert. It's expecting a what? A Boolean value. So we're going to do the comparison ourselves. If you look at this other assert macros, they are doing the comparison for us. All we have to do is just pass the values and they do the comparison for us. But if you're using the asserts, you can do the comparison yourself. So in this case now, if we are asserting like this now, this is just basically going to return a value. Dividing 20 by 2 return 10. That is not a Boolean value. So we want to compare it. Assert that dividing that is 10 equals to 10. So we know the results already. We can just pass that. Assert that that's 10. And that's a simple Boolean. And then we can pass the error message. You can pass the error message. How how many people have been able to follow up to this point. I want to know if anybody has been able to follow up to this point, any challenge you have faced. So we can solve that right now. Nobody, right? Because we have covered almost all the assert macro. So quickly, let me just mention the other assert macros that we have the assert LE, right? We might not touch every single one of them, but they basically work the same way. Assert GE. So what this is just assert greater or less than or equal to, and it still takes the same first value, the second value, right? And your error that you want. So do you understand that? Then similar for to that is the greater than or equal to, takes the same set of values. Right, you can always use that whenever you need, but I'll be getting rid of that. I don't need it. So as I'm testing my division now, I can say um, dividing 10 equals to 10, else we say division not equal to 10. And can run the test again. Now I can see the test is passing as expected. I believe you have been able to replicate this test and your tests are passing, right? If your tests are not passing, then you probably have an error somewhere that you need to resolve. So let's go back right into what we have to do for today. So we have covered introduction to testing, why we test, and we have written basic unit tests. Those are the basic form of unit tests that we've written using assert macros just to test functions. And next thing we want to do, I want to write in a counter contract, and then we'll test the counter contract to see a real world or a similar scenario of testing a contract. So what we can do right now, okay, before we continue further, let me introduce you to some other attributes that will be useful during testing. Some other attributes like should panic to handle scenarios where you. So in this case now, right, if you observe, we have just been asserting that um this value or our comparison works. So I've just been asserting comparison. Now I want to be able to test scenarios that are we want to test. Okay, I don't know the best way to explain this. Okay, let me say yes, this is how I explain it. So when we're testing smart contracts, right, we want to test positive and negative um or scenarios or edge cases, right? We're not always testing that the contract does something. We want to write some tests that handles edge cases in case the contract fails. We want to test it. So we want to have all the different kind of tests. That's why testing is very important. We want to test edge cases. For example, let's say something doesn't work or something works. We want to be able to handle all those scenarios in our tests. All right. And that's where we'll get to use the should panic attribute. right? So basically, the way the should panic works, let me just write a new test. And now in that case, I'll be testing these scenarios where the test fails. So this basically syntax is should panic, and then we're expecting this error, right? The error we're expecting. This is basically syntax. But now in this case, right, we'll now, okay, after writing those attributes, we can now define our function right here. Now we want to test that addition, right? Addition, test addition is not subtraction. I'm just giving random test as random as it can be. Right, but in this case now, we're not just testing that addition works, or let me say test addition should fail. This is a good way to explain the failing. So we have tested that addition works properly. Now I want to test scenarios, because in all those cases we're just making sure that this equals to this equals to this. But in a real world scenario, when we are testing smart contracts, we want to test all the edge cases of the smart contract working as expected and the contract working in random ways or not as expected. So this is where we now use the should panic. Now, what this should panic does is that once we've defined this attribute here, we write the expected error that we are expecting. All right. And if the test you run and through the error we're expecting, the test will be marked as pass. Right. Though the test failed, but because we have already specified that, okay, we know that this test is going to fail, but we expect it to fail with this expected error, it will be marked as passed. I don't know if you understood what I tried to explain, but then I'll just write a simple assertion. So let's assert that that addition of 5 and 20, want to assert that. Now, in this assert macro, it expects the comparison, right? So we want to compare something. So we expect the addition to fail. If we add 20 plus 5, we expect 25 right now. So we want to compare that this is not equals to, right? So we want to assert that 25 is not equals to adding let me just put the value here. I want to assert that it's not equals to 20. For example, all right. Now, in this case, we expect this to fail, right? This will not even fail, safe. This, right, because this is 25 and 25 is not equal to 20, and the comparison is correct. Right? So we want something that is going to fail. So that, let's compare this now. So the result of this addition, 5 and 20, is going to give us 25, right? So we want to assert that 25 is equals to 0, which is wrong. So these tests automatically should fail. But now, when we define the error we are expecting and we pass it to the should panic, all right, the test or the test runner undoes that scenario for us, that okay, we define that this is going to have this error, and because it has that error, the test is marked as pass. So let's say not not result not equals result not equal to what again? To 20. Let's just use that. Now we'll just copy the expected error and pass it here. Now let's try running the test. Now if you observe what happened here, you can see test addition to fail is marked as okay. You can see it here is marked as okay, and 5 tests have passed. But this assertion right here failed, right? If you look at this assertion failed, but the test is marked as pass. Why? Because we use this should panic attribute to test in the event that this test fails with this error that we defined here, and we expected this error. As far as we got the error we expected, is going to be marked as the test pass. But in the case where we don't get the particular error we specified, right, then the test will not be marked as pass. But if we do not specify the particular error we're looking for here, for example, whatever you can see it here, it says panic tweet results not equal 20. Now it's not able. Now this is the normal way the test would have failed, right? But because of we specified results not equals to 0 like before, that's why the test was marked as passed. Do you understand what I've been trying to explain in the past 5 minutes? Okay, only OB is responding. But basically, that's what I was trying to explain. The should panic attribute helps us to test scenarios that we expect to go the wrong way, to go negatively. All right, we can handle those scenarios simply by our test. Now, let's write another test of that sort. All right, let's say test, and let's test division by 0. Okay, now let's just try dividing by 0. Basically, in Cairo, dividing by 0, right? Dividing by 0 is going to panic. So now I'm not adding any should panic here, right? I just want to test it and see. So unexpected return type, expected this found, this, okay, returning properly. Okay, because without the semicolon is returning the value of 10 divided by 0. So now we can see it's panicking, right? Now, when you divide a number by 0, it's going to throw an error. So that now in this case, this is one of the kind of cases that we handle using should panic. We know that this scenario is going to give an error. So in the case that our contract, all right, let's say for example now we are handling a case where we expect the transfer of the asset or whatever is going to throw an error. Like this example now of dividing a number by 0, we expect it to throw an error. In the case that our division no longer throws an error, that becomes an error. That becomes yeah, that becomes an error. So we expect this to always throw an error. We always expect dividing by 0 to be impossible, right? So we expect this to always throw an error. So now we can undo that scenario of, but you can see is expect the error that is being thrown, right? This is thrown by the compiler itself. The error that is being thrown is throwing division by 0. So to make sure that test pass, we have to handle it using should panic attributes.
I'm sorry,
So
sir.
I'm just going to add that.
Before I go on,
Yes,
yes, sir.
yes, I can hear you.
Okay. And this testing now, these codes that we're writing, once we are
Yes.
done writing on testing code, are we going to like clear all the codes, then deploy the main contract, or we're just going to put in the tests and the contract together and then deploy both of them together?
So basically, that's what I was trying to explain to you. That basically, this is just a simple Cairo program, right? This is not a smart contract. This code is not a smart contract. This is just, Cairo is a programming language like any other programming language. So this is just a simple Cairo program that has a function, a main entry point. All right. A smart contract must have an interface and the implementation of the contract. So this doesn't have any interface and any contract implementation of storage or constructor or anything like that. It's just a simple Cairo program that we wrote to be able to test and learn about writing unit tests and assertions. Do you understand? So this is not some smart contract that we're going to deploy on the blockchain. Is that the answer to your question? Is that what you're trying to ask? Was I able to answer your question? I don't know if you're still there. So, but if you saw what I did now, I added the error message, right? The error message of should panic. If I comment this out, right, I remove the should panic here, and I just pass run this test. Now, dividing by zero is supposed to be impossible, so it's panicking, and the panic message is simply just saying division by zero. That's the panic message given by the compiler. Division by zero. So to handle that scenario, we are going to handle it using the should panic attribute. And if you look at this is a single colon, right? Is a single colon. Now, if you remember when we were talking about data types in Cairo, we have field 252, we have byte array. Now, if you look at all our other assertions, they are all in double colons, right? These are in double colons, and our should panic here is expecting the double colons. And why is that? It's because these are all byte arrays. These are all byte arrays. But if you look at the error message here, the error message is a failed 252. So our should panic, we're expecting a value of failed 252. That's why we have a single colon. So if you should put a double colon where you expect a single colon in Cairo, we have automatically changed the data type, right? So the colon colon or double tick or whatever is um yeah, it's basically a data type. So that's why we have it here like this. And if we run that now, because we're expecting it to panic with division by zero, when we run it, the test is going to pass. Why? Because it actually panicked. But based on our code, we expected that panic to happen, and it did happen. That's why the test is passing. So I think I've been able to explain that. Also, I've been able to explain should panic, is able to explain assertions, and I believe you have been introduced to um the Cairo book. So basically, the Cairo book is your go-to for everything related to Cairo. It has all information about Cairo. So even when you are moving on from you should always um take time to go through this documentation, and you can easily just search on different topics relating to what you're looking for. So basically, I've talked about assets, I've talked about assets, macros, writing tests, there's anatomy of a function. I've talked about that. I'm trying to, I've talked about should panic. So assert equals to assert not equal to, all the information you need you can find here. So I can just pass this in the chat. So you can always reference that later, apart from the slides. So what we're going to be doing is we're going to be writing a counter contract, and then we're going to be testing the contract and doing a little bit of integration test if time permits. I don't think we have so much time, but basically, integration test is supposed to be in session 2. Right, session 2 is going to be about introduction to Starknet Foundry, and that's when we're going to write integration test and really test our counter contract. But I believe we still have some time to go through writing our counter contract, and let's see if we can test tonight. So I can simply just in my terminal run create a new project, then scab new counter. That will be the name of the package, counter. Yes, we can accept to use Starknet Foundry because now we are writing the contract, and Starknet Foundry is used for testing Cairo smart contract. So now we have that, and we can just say code counter. I'll close this for now. I can always make that code available for you if needed. So we're able to create our new counter because this is what we're going to be using. So now scaffolding a new project with Starknet Foundry. That's what we just did. Now what that does, it installs some important dependencies and dev dependencies that we'll be using for testing smart contracts, right? So if you see, we have the um Starknet dependency here, Starknet package, the SN4 standard library, and the assert macros, right? We have all this. Target those Starknet contract. Basically, just Sierra is like the compiled version of this code we're writing here. So it's saying the target of this code is going to be compiled to Sierra, and we have the script. So whenever we run scab tests, this is the script that is being run, right? So by default, it uses the Cairo test runner. But whenever we run scab test and we have our scripts configured and we are using SNForge, Starknet Foundry, which is SNForge, just automatically runs the SNForge test for us, and then we have a simple. We can get rid of this and start writing our counter contract. Get rid of the test also. get rid of all of this. So basically, what um our counter contract basically is, it's just a simple counter that just counts numbers, right? Count numbers. Basically, that's all it is. So we can change the interface to I counter package, or the module is counter module. Can still leave this import because is it allows us to be able to access value from our storage. So this will be increase counter, decrease counter. We'll change this to ref. Since it changes the states, it doesn't take a snapshot of the states. Let this be get counter. Since we can leave that like that, our counter will be U64. To increase it by U64, get counter. Type for our counter is going to be U64. Pass it to the storage. So I basically just scaffolding is simple. So decrease counter is another function. But instead of this, we can just allow it decrease it by 1. Yeah, simple like this. So now we have our interface. Let's change both of them at once. Exactly. So this is, we have to import the I counter. Use super I counter. Are we following? So you can just take a time after this class to also write your counter contract. You can follow along from what I've done, because this is majorly what we're going to be testing. I'm majorly going to be testing this counter contract. So basically, it's a simple function. Can easily just copy this, paste this here. On grab, to grab this myself. So self dot counter dot write, self dot counter dot read plus 1. Yeah, we have to define the constructor also. Change this to contract state, not to contract. So the initial value, we want to always start our counter as 0, and then get counter basically just going to be the value of the counter. So yeah, we have this. So basically this is our most basic form of a counter function. This is what we are going to be using for testing later on and get rid of all these. Okay, we've got rid of all of that. All these dispatcher traits. We don't need them. So basically the way this contract works, it increases the counter which starts at 0, right? The counter in the constructor, the counter starts at 0, and then we increase the value of the counter. Whenever this increase counter function is called, it increases the counter by 1. Whenever decrease counter is called, it decreases the counter by 1. Whenever get counter is called, it basically just returns the value of our counter. Right, so it's just a simple counter value. We don't have much time anymore, but then today we have been able to cover some very important aspects in our introduction to testing. Right, in the next session, we're going to cover more advanced testing techniques and integration testing. Right, and today we talked about why we test, all right, how we test, the different types of tests, and we talked a lot on assertions and handling error scenarios during our test using should panic, right? So basically, I would like to ask a few questions. I like to ask a few questions since we are running out of time already. I would like to get a few answers also before we call it a night, right? So basically, can somebody tell me um can somebody tell me the uh the assert that we listed today? Can someone mention like 3 of the commonly used asserts that we use today? Is there anybody? Can anybody tell us the assert that we learned today? Yeah, you can go ahead and speak.
Okay, the assert that we use today, we use assert Michael, which make use of boolean and error values. Then we make use of assert, assert, assert equal, assert not
Yes.
equal. Yeah, and that's the three I know. So.
All right. So yeah, basically those are the most important part of what we've learned is if you were able to replicate it on your end, right? So that's how you learn these things. And while we are focusing on the very important simple part, because when you end up writing in large code bases, you see a lot of tests. You can see up to 400 to 600 tests where I just testing different parts of the application, right? And in those cases, it all boils down, especially in Cairo code, it all boils down to simple assertions, right? And more advanced techniques that we'll talk about in the next class. But then understanding how assert works is going to really be important in writing tests. And basically, because in the anatomy of a simple test is basically just a function, all right, that confirms or that verifies that the our program or our code functions or works as expected, right? It's basically a code that ensures that our code. So you are basically just using code to test code. That's simply what the test that we are talking about is. And I believe this is the simplest form of counter contract, and I hope you'll be able to replicate this, right? By our next class, I would write a more fuller version of this contract and test it. Right now, in that case, when we're going to be testing, we're going to be doing integration tests. Right, so we're going to be doing integration tests for this contract. Right, so we're going to set up, we're going to deploy, declare the contract all in our test environment. Right, and then we're going to use the contract to use the SM Forge library, which is the testing library for Starknet, to yeah, and sorry about that. I'll cover custom error messages also. Right. So basically, right now, if anybody has any question, can go ahead and shoot your questions, whether it's related to this, whether it's related to what we've done today or not. You can go ahead and ask your question before we end the class for tonight. Okay, I believe nobody has any question. Or does anybody have any question? Whether it's related to this or not. Anybody? If there's no question, we'll end the call. Yes?
Mine,
Yeah, I can hear you now.
mine is not more such of a question. It's like a problem. My Cairo environment, I haven't set it up yet. I'm having difficulty setting it up from the beginning. Like I can't install my WSL. That's just what is holding me since I've not
Okay,
been
you're
able to
using a
code
Windows
since.
device,
Yes, sir.
and for the past 6 weeks, you've not been able to install your WSL. So how have you been following the class? Don't worry, we'll not be able to
Ah,
do that live on this call, but you can text me in my DM, and I'll try my possible best to help you. There are also staged their environment, their virtual dev environment that they have set up for Cairo programming that you can also use to if you are still unable to set up your WSL. But then you can text me, I can help you set up your WSL. I have WSL on my Windows. So that's that. If there's any question related to the class. But basically, I just want you to try to I can send the code for the
oh,
counter
very much.
contract.
I'll DM you.
Yeah, I can send the code for the counter contract if you need, but else just write a simple counter contract, because that's what we're going to be using to test in our next class. All right. So good night, everybody. Thank you for joining.